Good morning, good afternoon, or good evening. Welcome back to the channel. In today's video, we're going to take a look at Cisco Modeling Labs and Claude. And through MCP or Multi-Context Protocol, we're going to essentially be able to utilize Claude as an AI assistant to tell Cisco Modeling Labs what labs we want to build, how we want to construct them, and how to configure them. So without any further ado, let's hop right into it. So we're going to do a couple things. So we're going to reference this website, which I will provide in the description of the video. This is the GitHub page that tells you exactly what we're going to do today. Then we're going to go ahead and download and install the Claude Desktop agent. From there, we'll install UVX, which is simply one PowerShell command. And then the only thing we'll have to do beyond that is to modify the JSON file within Claude so that we point it to the CML server and its username and password. And then finally, we'll have some fun and we'll use a prompt. So we'll get to this in a few minutes. But essentially, I'm going to throw a whole bunch at Claude and see how it handles it. And we'll see how it does, what works, what doesn't, what corrections need to be made, all that good stuff. So let's go ahead and let's go to the GitHub page really quick. So this is what you'll be presented with on the GitHub page. And if we scroll down, we can see that we're going to essentially do exactly as I said, right? So when we're done, we should be able to interact with Cisco Modeling Labs using natural language through AI, in this case, Claude Desktop. And again, the installation goes through to tell you how to install UVX, like I said. It tells you, it gives you the sample file or the contents of the file, which is Claude underscore desktop underscore config.json. And again, from there, away you go. So I'm going to go ahead and hop over to the Claude download page. I'm running Windows, so I'm going to download the Windows exe file, and I'll go ahead and get that installed. Okay, so once you have Claude installed, you'll basically be presented with a screen similar to this, which is essentially the chat box where you would ask it a question. Now, a couple things really quick. I am using the Pro plan. You do not need the Pro plan to do what I'm going to show you. The only reason I'm using the Pro plan is because I want to be able to play with this more and more. And the free version limits you to how many things you can do in a single day. You'll have to essentially wait a couple hours for it to reset if you oversubscribe your free capability. So again, that's the only reason I'm using the Pro plan here, but you do not need it. Now that Claude's installed, let's go ahead and install UVX. So I'm going to go back to my cheat sheet here, and this is the link. So if we go to the link, you'll see installation UVE. So I'm doing it with Windows. So I'm going to want to make sure that I select Windows for the installer instructions. And then they literally give you the PowerShell script, which you can copy to your clipboard here. So all I'm going to do is take that PowerShell command. I'm going to open PowerShell as administrator. And I'm going to paste that in there and hit enter. You can see that it goes ahead and it downloads the UVX exes, and then it goes ahead and installs everything. So literally that's all you need to do there. And then if we look at our instructions, at this point we're ready to modify the Claude config.json file. So I'm going to take this and copy it. I'm going to head back to Claude, and to get to that file, you click on your username down on the bottom left, you go to settings, then you go to developer, and you can see local MCP servers. Right now, there are none. We're going to change that by saying edit config. It takes you right to that directory where that config file's at. Literally, you just double click it. I can say open with Notepad, and I'm just going to blast in the contents of the website in there again. Make sure you point to your CML server and make sure you have the correct username and password. When you save this, make sure you do a save as and make sure you say all files because you don't want to save it as a text file. You want to make sure you save it as a JSON file. So I'm going to hit save. It's going to ask me, do I want to replace? Yes, I do. And then from there, I can close all these windows and then I can literally exit and relaunch Claude. Now, if that worked properly, what we should see is if we go back to the developer section and we go to local MCP servers, we can now see that Cisco Modeling Labs is running, and we can see that the command it's going to use is UVX, which we've installed via the PowerShell line. Okay, so this all looks good. One other thing we need to do is we need to go to connectors. And inside connectors, you should see a Cisco Modeling Labs connector now. So you're going to want to go ahead and configure that. And in my case, I have basically turned on every single option that they allow me to use. So always allow, and you basically want to just check off everything. You don't have to. In my case, I'm just allowing everything. All right. So now if we go back to the new chat, what I would suggest from this point is just testing out your MCP integration now. So we can say something very simple like, show me my labs. And let me go ahead and point my web browser to my CML server. And I'll log in with that same username and password. Okay, so right now I have 3 labs. I have SD-WAN, SGTs, and Cisco TrustSec. So let's see what Claude comes back with. Let me maximize this. So I just asked it very simply, show me my labs. Comes back, tells me here are my 3 labs, tells me that their status is stopped, right? Gives me a little description, tells me my SD-WAN lab is my largest one, okay? SGTs is a little bit smaller, and then Cisco TrustSec, is the newest lab. So this is a good sign. It tells me that I'm now able to interact with CML via MCP just fine. So let's go ahead and have some fun now. Let's go ahead down to my prompt. So I'm going to copy this prompt, and I'm literally going to blast it into Claude. So really quick, so all I'm doing here is I'm saying, hey, create a new lab called AI Gen MPLS. The lab should contain 6 routers, 4 of which make up an MPLS cloud. Okay, 2 of those 4 routers are provider edge routers, and I tell it what names I want to use. So Verizon PE1 and 2. The other 2 routers are route reflectors and should be named Verizon P1 and 2. The MPLS cloud should have, let me fix this. I'm going to say the PE routers should have connections to both P routers inside the MPLS cloud. All right. There should be 2 customer routers named San Jose Customer Edge 1 and New York City Customer Edge 1. The San Jose router should connect to one PE, and the New York router should connect to the other PE. The San Jose router should have this prefix. So I basically took 10.1.0.0/16 and New York City has 10.2.0.0/16. So fairly large subnets, but just basically 1 and 2. They should both advertise their prefixes to the provider edge from BGP AS 65,000. So in other words, both branch locations should have the same AS, which is 65,000. Add 2 switches to the topology. The first switch should be named San Jose Switch 01 and connect to the San Jose router. It should be configured with VLANs 10 through 20 along with SVIs. These SVIs should be advertised to the San Jose router via EIGRP. And then I go on to say basically the exact same thing for the second switch, except it's all pertinent to New York City. And then I say, finally, configure everything in a way such that New York City Switch 01 and San Jose Switch 01 should have reachability to one another. So that's a lot, right? That is a lot. It's a big prompt. There's a lot of configuration behind the scenes that has to happen here, specifically inside the MPLS cloud, multiple protocols, multiple technologies. And notice nowhere in here did I specify what kind of router I want to use. So there's definitely some assumptions that have to be made with this prompt. So let's go ahead and just fire away. Now, obviously, none of this is going to be instantaneous, but it's also not going to take that long. So I'll pause things as needed as we go through this. But I definitely want to kind of show the process that this follows and the wealth of information that it provides. So notice the first thing it says is okay, great, I'll use iOS V for the routers and iOS VL2 for the switches. Let me create the lab and all the nodes with the full configurations. So it's going to create the lab. It's going to add all the nodes. And what it's going to do is it's going to compose those configurations as a startup configuration. And that way, when I'm ready to start this lab, it'll just boot all those devices with the startup config that it comes up with based on that prompt. It basically says now all 8 nodes have been created. Let me connect them. First thing it needs to do is figure out where it's going to connect them. So as this is thinking, let's go back to CML and look at that right before our eyes. We've now seen that AI Gen MPLS lab has appeared. So I'm going to click into it and we can see it's kind of doing its thing. It's working as we speak. And the other thing that I think is really cool here is that it's placing these devices uh, kind of in a way in which it's going to make sense. So in other words, all the Verizon routers are in the center. That's going to be the MPLS cloud. Then it even knows to put the edge routers next and then the switches behind it. So it's positioning these things in a strategic way. Let's go back to the prompt. So I've gotten all the necessary information. Let me note the complete interface mappings and proceed to wire everything up. So it tells us, takes all the node IDs. I still need the interfaces for New York and San Jose. Okay, so you can see here, right? This is where you start to run into the limitations. It hit its tool limit for this turn. All we got to do is hit continue. All interfaces have been collected. Now let me wire up the topology. So it's actually giving us an interface map, which is pretty awesome. So it went ahead and figured out which devices have what interfaces, and now it's telling us which interfaces it's going to connect together. So if we come back here, we can see it's literally wiring this thing up before our eyes. My hands are here. I'm not doing anything. This is all Claude doing its thing. And notice the provider edge routers, just like I had asked, I told it to make sure it has a link to each P router, right? So looking good, right? So now it's doing the configurations. So it's starting with, in this case, it's starting with Verizon provider 01. My guess is this going to take a little bit of time. Looks like it's heading over to the two switches. All right, so it comes back, it tells me all configurations have been applied. The lab has been fully built. Here's a complete summary of what was deployed. Gives me a little topology overview, which this is okay. All right, gives me a breakdown of the inventory and the IP address schemes. So this is really cool. So provider router is a route reflector. Tells me its loopback address and the interface mappings for basically every device, which is pretty awesome. Now let's look at the protocol stack. So it looks like it used OSPF Area 0 for the MPLS core, P and PE loopbacks and core links, okay. Then it knows it needs to configure MPLS and label discovery protocol or label distribution protocol, right? So that's good. It knows that it needs to do multi-protocol BGP to essentially reflect the routes from customers to either side of the cloud. Looks like it used BGP AS 65000 for, excuse me, I asked it to do that actually. So the customer edge router should be configured with that autonomous system number. It definitely knows the subnets based on the prompt, based off the prompt. So it knows about the VRF customer. So it took care of the route distinguisher and the route targets. That's awesome. And then it actually chose an EIGRP autonomous system number because remember, I didn't specify that. And it knows that it needs to redistribute those SVIs into BGP at each customer edge router. This is pretty impressive, right? End-to-end reachability, it even shows us what, the network path should look like once we're ready to kind of test this. So let's come back over to CML. Again, nothing's been started yet, right? So essentially all it's done is position the startup configs for all the devices and spit out the summary for us. So let's go ahead and before we start the lab, let's go ahead and tell it, let's say, please add annotations and colored blocks around the relevant network segments. Use an automatic method to do so. So in other words, make this thing pretty. Okay, so I'll fetch the node positions from the lab to automatically calculate annotation boundaries, then add colored blocks and labels for each network segments. So it looks like it grabbed coordinates. I'll calculate bounding boxes automatically for each segment. Gives me the colors. This is wild, guys. All right, so we head back to the lab. Let's see how it does with this. This is hit or miss sometimes. That's why I specify automatic, because sometimes it'll orientate the blocks in kind of a weird way. But so far, it looks like it's doing pretty well. Okay, so it gives me a summary of all the annotations. Pretty cool, right? So awesome. So let's go back and see what it looks like. That's not bad. That's actually pretty good. I'm not necessarily seeing the annotations, though. It just did the blocks. But that's fine. Okay. I mean, it did a pretty good job, right? All right. So let's go ahead and say start the lab. Look at this. CML is staggering the starts to manage host resources. This is normal behavior. All 8 nodes are queued. Wow. gives me the image version, memory and CPU, gives me an idea of how long it normally takes these nodes to boot. Once all nodes reach the booted state, the protocols will begin converging. 1. OSPF will form adjacencies across MPLS core first. LDP will exchange labels. Multi-protocol BGP will advertise across the cloud, the core. EIGRP will form between each CE and its connected switch. And then finally, BGP sessions will establish and exchange the VPN prefixes. Super cool. So coming back over to the lab, it definitely looks like everything is in a green state, which is good. So let's go ahead and console into the switch, the CE, and one PE. So again, this is going to take a few minutes depending on how powerful your lab is. So the routers are still doing their thing. Looks like the switch has booted. It's got a host name. Let's do like show VLAN brief. So, okay, so the VLANs aren't there. So that's obviously not ideal. So let's give this a couple minutes to see how it does. So it's interesting, right? So the switch has the SVIs. So it did a nice job with VLAN 10 through 20, and then it looks like it manipulated the third octet, which is pretty awesome. But it doesn't look like it created the VLANs, which is kind of funny, right? Now maybe that's an order of operations in which it shouldn't be, right? Because it was a startup config. But let's wait for everything to boot, and then we'll kind of troubleshoot using Claude and see how far we get here. Okay, so it looks like on the left side of the topology, we've got our CE router. So let's go ahead and just let's check show IP interface brief. Looks like we've got our interfaces. If we do show run section EIGRP, it's definitely got that. Show run section BGP. Okay, good. So it looks like it's got the necessary BGP to peer with the Verizon PE. Even gives a description, which is pretty awesome. Okay. Show IP EIGRP neighbor. So we've got our neighbor to the switch, which is awesome. Now, before we actually, let's do show IP BGP summary. So it looks like we've got our BGP peering with the provider edge, albeit we're not learning any prefixes yet. Maybe it's a timing thing, or it could be a configuration issue. So we'll give it a second. If we go over to Verizon PE, we see console messages that indicate OSPF is up and running, as well as LDP, so that's all good. If we do show VRF, we can see we've got our customer VRF defined. Show BGP VPN v4 unicast all summer. Okay, so right now we don't have the peerings with the route reflectors. However, we do have a peering with the customer edge and we're learning prefixes, so it's kind of working. Again, this may be a timing thing or it could be a config issue. We're not really sure as of yet, right? We know just based on the switch config, we know that we don't have the VLANs. So, I mean, that's one thing I can spot pretty much right out of the gate here. And like I said, we're not learning prefixes, most likely because of the route reflector peerings being down. So let's go to the other PE just to see if it has the same issue. Show BGP VPN v4 unicast all summary. Yeah, so it looks like it's the same state. So let's go back to Claude, right? And let's say the Verizon PE router IBGP peerings are not working. Also, the VLANs on the New York City and San Jose switch are not configured. Okay, so it thinks it's verified the IP scheme's fine. It says they're correct. It says the real issue is that the PE configs use update source loopback 0, peering to the provider loopbacks. But OSPF needs to be fully up first, and the configs are loaded at boot. Let me inspect the actual issue by checking the node states and reviewing. So, and then for the VLANs, it says, oh, okay, fine, whatever. So we didn't do the Python bit, so it can't run live send CLI commands, which is fine, but it should be able to figure it out based on like console messages. The console logs is very revealing. I can see the root cause clearly. The BGP issue, it says they're stuck in the idle state, which we've already seen, even though OSPF and LDP are fully up. The problem is the PE configs are missing the neighbor statement. One other outfit is more critically. This happens when update source loopback 0 is configured, but the loopback isn't reachable yet at config load. Okay. The fix is to push clear IP BGP. Okay, that's interesting. I don't know if that's going to fix it. The cleanest approach for it to fix this is to wipe the broken nodes, repush the corrected configs. So it's going to say it's stopping those 4 nodes, it's wiping them, and it's going to push brand new corrected configs, or what it thinks is corrected configs. Now, again, you can start to get in the weeds with this. So I don't really want to throw a percentage out there, but in my experience, depending on how complicated your labs are, uh, I'd say it's definitely positive. It's not a bad percentage, but it's definitely not 100%. But it's usually pretty close. Okay, so it's restarting all 4 nodes. So we'll see what state we get from here. And I'm not gonna beat this up too much. I mean, if it can't figure it out 100%, I think this is more of a show and tell kind of thing, just to show the power of Claude and CML. I think it's a great learning tool, but again, it's not quite perfect, right? So it says it thinks it fixed issue 1, which is the IBGP. And then, okay, so it looks like it mucked with the VTP mode. All right. So let's see. Let's go back to the console. All right, switch looks like it's back. So let's see what we see now. Okay, so show VLAN brief. Aha, so that's much better. So now we've got VLANs 10 through 20. Why did the console just... Okay. Oh, it just stopped them. What's it doing? Okay, so it looks like it's applying more fixes. Okay, we'll give it a second. Wow, it's doing something with the whole MPLS cloud and the switches. Okay, fine. Wow, it's even recognizing supported commands versus unsupported commands on iOS v15.9. I gotta say, this is pretty impressive. Okay, so it's addressing the switches. I'm not sure what it's doing. All right, let's see the summary here. What the console log revealed. The boot log for the Verizon PE router showed this error immediately. BGP reconnect interval 10. Again, I don't know if that's the problem here, but it's cool that it recognized that. Oh, it had peer groups configured. So that might have been why. So if the peer groups were configured incorrectly, that's very well could have been the reason for IBGP not coming up. Okay, interesting. Um, looks like it's queuing them. Okay, yep, it's starting to bring everything back. Okay, all 6 have been started. Let me wait for boot and then check the console logs. It's basically going to look for the console message that says BGP neighbor up. See, I don't know why it's even trying to mess with BGP timers. Like, just leave it at default. Like, this is where it starts to get, like I said, you start to get in the weeds a little bit. It shouldn't even have tried to monkey with BGP reconnect and timers and all that. Just leave it at default, right? Like, and you won't have an issue. So now it's stopping, wiping, and repushing the MPLS again. Okay, so customer edge side. Okay, show IP route. Fine. Show run section BGP. All right, so once this provider edge comes back up, I'm hoping. All right, so it definitely found what it thinks is issues, saying, please press continue one more time and I'll push the final config. So let's see what it does here. And then we'll wrap this video up because I think at this point we may have gotten as far as we can, but we'll see. We'll see if it's working or not. Either way, this is really, really powerful. I mean, the amount of time it would take to do this manually, I mean, regardless of laying the topology out, connecting all the links, making note of what connects where, what IP schemes you're going to use, all that, right? Like that takes time. And then not to mention all the underlying technologies within the MPLS cloud. you're probably looking at a few hours worth of configuration. Even if you have all the commands committed to memory, it's going to take a little bit of time to get this fully configured. So let's see. So everything's almost fully booted. All right, we got to be close. Let's get this command staged. So hopefully, once we verify BGP now, I'm hoping we see some better results. At this point, we're just waiting on the 2 PE. Oh, looks like PE1 should be good. Let me reconnect to the console. And then same here. All right, here we go. How did it do? Okay, so the CE has the BGP message up, so that's good. Let's go back to the provider, right? So we can see OSPF came up, which is good. LDP looks like it's up for both neighbors. BGP came up. That's all looking great. Show IP route for, what was it, VRF customer, I think? Show VRF. Show IP route VRF customer. Okay, this is awesome, right? So now PE01, which is on the bottom left of the cloud, it definitely has BGP routes in its table, which means they're being learned from New York City. So if we go all the way to San Jose, let's do a show IP route there. So this is promising, right? So we can see it's got a BGP route for 10.2.0.0/16, and it's also got 172.16.2.0. So my guess is this is the IP address of the switch. So let's verify that. show IP interface brief. We can see gig 00 has an IP address of 172.16.2.2, and that's the exact prefix we learned in San Jose. Perfect. So let's do this on San Jose switch. We should be able to source a ping. So let's do a show IP route. So it's got a static route to point to the router, which is perfect, right? So if we do ping 172.16.2.1, source it from 172.16.1.1, what was it? Oh, 1.2, sorry. And I think it should be 2.2. Okay, so I can ping. Now let's trace route that. Trace route 172.16.2.1, source it from 172.16.1. Sorry, I did it again. 2.2 and 1.2. Trace route 172.16.2.2. Should have did numeric. Okay, so it goes to the router. That's its default route. Next hop. All right, so from the router, it looks like it's going to the PE. That's my guess, 192.168.1.1. So then it enters the MPLS cloud. We can see labels, which is awesome. So then this is the other PE on the other side. So that's PE number 2. It should pop the label, go to 2.2, which is now New York City CEO 1, and it should make its way there. Yep, 172.16.2.2. So, okay, so I gotta say, I don't know what the length of this recording is right now. It looks like we're at, with all the pauses and stuff, I mean, we're at 52 minutes right now. But with the pauses, reboots, and the corrections we had to make, I'd say that maybe a half hour. We had Claude, based on the one prompt I gave it, generated this entire topology, figured it all out, and we literally have reachability from San Jose Switch 01 to New York City Switch 01 through a real MPLS cloud, and we didn't have to type a single command. If that's not power of AI, I don't know what is. I'm genuinely impressed. Hopefully this resonates with you guys. Hopefully you enjoyed it, and I do look forward to seeing you on future videos. So take care.